Today's lesson is on subtraction using gains and losses and can be found on page 143. You can rewrite expressions as gains and losses. So we're going to start by going over basically our little kind of cheat sheet that we can use to help us figure out whether something is a gain or a loss. So when you add a positive, that is the same thing as a gain. That's an overall gain. When you add a negative, that's actually an overall loss because you're adding negative, so you're getting more negative. When you subtract a positive, that's a loss. But if you subtract a negative, if you get rid of what you lost, you actually are gaining. So basically, if there's two of the same, it's like adding. And if you have one of each, then it's like a loss or subtracting. So what we're going to do is look at our series of questions and go, okay, plus 3, well, that's going to stay the same. We have a gain of 3. Now, our next number will be 5, but to decide what symbol needs to go there, we look at the two symbols between it. So we add a negative, and if we look at our chart, when we're adding a negative, it's the same thing as a loss. So we would put minus in the middle. So it'd be plus 3 minus 5. If we were to look at a longer example, we would do the same thing, but it might take us a little bit more time. So we start at the beginning. Plus 4. And there's only one symbol, so we know that that's a gain. Our next number is 6, and we have to look at the two signs between it. So subtracting a negative is an overall gain. Our next number is 5. To figure out the symbol between it, when you add a negative, that is a loss. Then we're going to add a positive, which is a gain of 3. We subtract a positive, which is a loss of 7. So for question 1, that is all you are doing. For question 2, we're doing something quite similar, but we're using letters instead. So we would have A. When we add a positive, that is a gain of B. Okay, so you'll just do that, but it's letters instead of numbers. Question 3 will get you to complete the step we've just practiced and take one step further. So you simplify the expression, and then you're going to add your gains and losses. So they say add, but it might seem more like subtracting to find the result. So if we start with this first example, we have a loss of 5, and then when we add a negative, that is a loss of 3. So when you lose 5 and then you lose 3 more, you have an overall loss of 8. So this is just that final step that we're doing to finish. Question 4 is going to be set up a little bit differently. It says, do you need a gain or a loss to get to plus 3, and how much do you need to gain or lose? So they'll tell you where to start and where to end. So if we start at negative 2 and we want to end at positive 3, so we've lost 2, do we need to gain or lose to get to positive 3? Well, we need to gain to get to positive 3. And there's a couple ways to figure out how much you need to gain, right? So you could think of a number line, and you could go negative 2, negative 1, 0, 1, 2, 3, and go, okay, 1, 2, 3, 4, 5. I need to gain 5. You could also think of integer chips. So you could start with, okay, I have 2 negatives, and I'm trying to get to positive 3. So 2 positives will help me cancel out what I have here, and then I need 3 more positives to have 3 positives on their own. So this would make positive 3. So you notice I added 5 positive integer chips, which is why I have a gain of 5. So just 2 different ways to think about this. Question 5 asks you to fill in the missing integer to make the statement true. So they've given us positive 3, and we need to add something to get to negative 1. So you could use your number line and figure out, are you moving left or right? I'm going to use integer chips just to give you guys an idea of another strategy. So I've got my 3 positives and I want to end up with -1. So I need to add things to this. So I need to add more chips. I can't take any away. So I'm going to try adding negatives because that should make my number smaller. I want to make this a loss. So if I add 1 negative chip, then this overall is +2 because this cancels each other out, so I'm left with 2. So I can add another negative, and this overall, these cancel out, so I'm left with +1. If I add another, that means I am left with 0 because they all cancel each other out. And if I add one more, I'm left with -1 because these cancel each other out and I have 1 negative. So I added 4 negative chips, which means I need to add -4 to make this statement true. Now, don't get confused about the fact that this is actually not the same as your question A, okay? I did change up one of the signs, so this will not be your answer, so don't get freaked out if you got something different. Question 6 asks how you could use your answer to part C to check your answer for part A. So I'm just going to quickly demonstrate what a part C might look like in this case. So it might look like -1 plus something, minus something equals +3. So we're starting at the same beginning and then going to the same end. So if we were to look at this and go, okay, I have 1 negative. I need to subtract more negatives because I want to gain to get up here, right? So in order to be able to subtract negatives to get to +3, well, I'll need to have 3 positives in here somewhere. But I need it to start at -1. So if I give each of these a matching negative, overall, this gives me -1 because these cancel each other out, so I have 1 negative left over. So then, if I take away all of my negatives, because I need to take things away, I'd be left with 3 positives. So I could take these out, and so then I'm subtracting -4. Okay? If I were to use a number line, I could also go, okay, I'm starting at -1, and I want to subtract to get to +3. So if I'm subtracting, when I subtract a negative, I'm moving to the right, and when I subtract a positive, I'm moving to the left. So I could go, okay, I need to go to the right, which means my sign needs to be positive, and I would need to go 1, 2, 3, 4 spaces to get to +3. So that's another way that you could get the same answer. So you might notice that we got the same answer in the middle, right? So if you think of A plus B equals C, that always means that C minus A is B and C minus B is A, right? If we replace these all with 1 plus 2 is 3, so then our C is 3 minus A is 1 equals 2, and that's true. And 3 minus 2 equals 1. Yeah, it all matches up. So there will be a Google form attached to this assignment. Please fill it out. Remember to please ask me for help if you need to set up a Zoom call to go over things, because this is a pretty tricky unit and we're not in the classroom to work together.